Okay. Back on record. Okay, we're back to share. Okay. So let's talk about concurrency first. So when we're in model view controller, concurrency works this way. It's actually pretty simple, and it's the way that most of us are used to programming. I have a function call, and that when that function call returns, then I continue on to the next thing. So if my function call is find movies to a server, if a client is asking find movies to a server, I block until I get the list of movies back. Then I can do pay for movie. When I select the movie I want, I get a receipt back. And then I can say, hey, I want to watch this movie. So I pass in the movie and the receipt, and I get the movie stream, and I can watch the movie that I want to watch, right? Each request in model view controller is handled by a thread, right? And that thread blocks until it's fully processed, and I get that back. So on the server side, when I ask for a movie, that a thread is spun up, it goes and finds it, and then it returns it, right? And I'm blocked during that time, right? There's some benefits to this. If I have a really chatty client, or a client that is, maybe a DoD attack, a denial of service, a DOS attack, then I won't overwhelm the server per se, right? Because the server's blocked, and it puts natural back pressure on the clients. Okay, so it forces that client to wait until I get the response back. So I can't overwhelm the server nearly as much. If I do a distributed denial of service attack, then I can overwhelm the server with that. Okay. It also eliminates the need for end-to-end rate controls that you get with other systems. So there's some benefits to this synchronous way of doing things, right? A server, in order to handle all these requests, a server will need several threads to handle bursty clients and clients that are chatty, right? So there are two types of threads in Java 19 and above. There is platform threads and virtual threads. And we'll talk about the differences in those here in a little bit. Okay, so just to understand, with model view controller, it is synchronous, not asynchronous, meaning I am blocked. I put in a request, I wait for the response. So I am blocked waiting. Okay, that's critical to understand that. This is called synchronous concurrency. Synchronous. Asynchronous is something that we'll talk about for assignment 2 and 3. And that uses something called web flux, which we can talk about. In fact, I'm going to touch on in just a little bit. As far as communication goes, all network communications in the Java boot or Spring Boot framework is with common Java types. And here's a list of the common Java types that are out there. These are really important to use when you're writing your services, that you're using these types. Why? Because the controller is going to marshal and unmarshal these data structures for you. And that saves you a lot of time. And when we talk about marshaling and unmarshaling, just the easiest way to describe it is I can take a data structure and create a big old huge string and send it across the wire to the other side, and then where I can unmarshal that string into a data structure. So that's the concept, is I take a data structure, I produce a long bit of strings, or a long string of bits, or a long whatever, right? A whole bunch of bits that I'm sending over, and then I can reconstruct the data structure on the other side. If you use the common Java types, that happens for you automatically, which is wonderful, because I'm not really passing a full data structure over intact when I send it over, right? It's being streamed over. Okay, so make sure that you understand what these collection map, iterators, sets, lists, queues, understand what each one of them does and how to use them effectively. This will save you a lot of time. Okay, so this is a good reference slide for you guys to look at. All right, let's talk more about communications. Remember, model, view, controller, endpoint, send and receive Java collections back and forth. So if I ask in this instance, I'm asking for airports across the world. The client's asking for the server. I'm going to get a list of airports coming back, right? And it's going to be a list, a Java list, okay? There's a problem with this though. What if the server has to go out and run a bunch of queries and maybe it's hitting IO and things like that? That list of airports could be very large as well. It could be megabytes large. There could be thousands, tens of thousands of airports being passed back. All of that comes back into a list of airports. Okay. So this means your client could be waiting for a while. And this is where we get that notorious spinning icon, waiting icon, the spinning hourglass, the spinning cycle that we get. That's when the client is waiting for the server to respond. If you're getting that, then you know I'm doing something synchronously. Right? That's one of the tips to synchronous. The other downside to this type of model is if that list of airports is really large, let's say it's gigabytes large, then I've got to bring all that into memory and send it across and bring it up on the other side, all in the memory, because it all comes in one packet across. Okay. Another approach to this is using WebFlux. WebFlux, which we will be using later, but go ahead.
Hey, you fine. I cannot tell you. Thank
I'll mute LaShawn there for a second. All right. WebFlux allows us to do reactive programming where I'm asking for something and I can get the responses back without blocking. So I can get those responses back as I get them. So this allows me for more asynchronous programming. But we're going to talk about that more for assignment 2 and 3. But I just want you to know not all is lost. But that remember, WebFlux, asynchronous programming, model view controller in Java Spring Boot is synchronous programming. Okay. Any questions on that? We got that. Okay. Let's move on to threads real quick. We are low on time. All right. Real quick on threads. There's 2 types of threads in Spring Boot. We've got normal threads. Platform threads is what they're called. There's a thread by itself is just a sub process, and it's considered the smallest unit of processing in the computing world, right? Programs can perform multiple tasks by running multiple threads, and they can run them in parallel. Okay. Some of the more modern languages like Node.js is single-threaded, which means everything runs in one thread. With Java, it's multi-threaded, and there's always a main thread, and that's typically tied to the main of the program. And then other threads, if I wasn't using Spring Boot, other threads you can program using the thread class and extending the thread class. In Spring Boot, I can do the same, but I don't have to. Aaron, go ahead with your question.
Yeah, I had a question on WebFlux. So I'm used to like programming models where you have the ability to do like async await. So like you're not blocking the thread. The thread can keep processing, but WebFlux seems like it's a little different in that, let's say I've got 500 megs of data to pass through. Like I can chunk those into pieces and send them out piece at a time. So like I'm not holding that whole thing in memory. That's what it seems to me like you're saying.
That's one of the aspects of WebFlux. Those are the reactive streams.
Mm-hmm.
So so that's just one aspect, Aaron. So we'll go in more depth on that later in the course.
Okay.
And if you're interested, you can look ahead on some of the weeks, or send me an email or something in the discussion thread, and I'll send you some links,
Okay.
or you can research that some more. Okay. Real quick, threads and virtual threads, because I know we're out of time, and I do want to cover this real quickly because we'll go more in depth on it as well. With Spring Boot, it handles creating a thread per request for model view controller. So it'll handle those threads for you, which is great. But there's a downside to platform threads, is what they're called. There's a one-to-one mapping with the platform thread and an OS kernel thread, which means I'm limited on how many threads I can run. And limited meaning in the thousands. Okay. It contains a unique state as the traditional Java thread. So it copies a whole stack over. So I know where I've got a full stack of registers and all that. And the minimum stack size is about 1 megabyte. So if I have thousands of these, that's a gigabyte of memory right there, right? It also uses the OS to schedule the platform threads on when they get time in the CPUs. Now, I can assign threads per core or threads per thread. Like with Intel processors, they're multi-threaded processors. So I can assign threads, these platform threads, to the individual threads in the CPU as well, right? These are really suitable for any task at all, especially tasks that want to use any of the OS resources. Okay. And they do take some time to spin up. But this has been the thread model that we've had in Java for decades. With Java 19, they introduced virtual threads. Now, virtual threads are pretty slick. They're very lightweight, and they're managed by the JVM. So they write on top of platform threads, and they're decoupled from the kernel threads. And each platform thread can have thousands, tens of thousands of virtual threads in them. And they can start up really quick, which means I can have millions of these threads operating, and I don't have as much information that's being passed with the thread. So context switching is much faster as well. I only bring into memory what's needed dynamically at runtime. So memory is allocated on demand as I need it. And they're not going to block the underlying platform thread. So that's the main difference between the two. We are going to go more in depth on virtual threads later, but I want to give you guys an idea of what these are. These are new in Java 19. Okay. All right. We've covered a lot today. Any questions? I'll stop the recording now. Any questions that we have? I'm going to be available for the next 45 minutes or 40 minutes. But the lecture part of class is over, done. So does anyone have any questions?